Okay, second part of the factorising video. Factorise the following difference of perfect squares using surds. Okay, so these look similar to the ones we did above, but you may notice that the second number is not a square number, and because there's no highest common factor, we can't take anything out. We can't, so it doesn't present as a square number. So one thing we can do is we can use surds. So we learned about surds in the last chapter, and one thing we can sort of think about is so 10, for example, how you can write 10 as a square number, and you can do it because if you remember, the square root of 10 all squared is equal to 10. Okay, so the square root of 10 is a surd, so square root of 10. Okay, so what we do is x squared minus the square root of 10, all squared. Okay, I might actually just blow this up a bit. Okay, I might just quickly go back. Okay, so all squared. So we've technically got two square numbers here because the square root of 10 squared is 10. All right, so we go back to our difference of perfect squares rule. It's the first number minus the second number, which in this case is root 10, and the first number plus the second number, which is root 10. Okay, and that's fully factorized. Okay, it doesn't have to be a square number to use the difference of perfect squares rule. All right, so this next one, again, 24 is not square, but we can make it into a square by doing this. X squared minus the square root of 24 all squared. Okay, so what we should do here, and the reason this one is different to the first one is because 24 can be simplified. Actually, we'll do that at the end. Okay, so our rule for perfect squares, difference of two squares, is x minus the square root of 24, x plus the square root of 24. Okay, so now what you have to realize here is root 24 is not fully simplified. So square root of 24, just doing a little thing here. Remember, 24 is the product of 4 and 6. Okay, if you remember back to your surds unit, we can simplify that to 2, because the square root of 4 is 2, root 6. Okay, so in actual fact, this one, even though this is correct, this one here, we should simplify it to root 6. Okay, so replacing that negative root 24 with 2 root 6. Okay, so that's how we factorize that. Okay, the last one here, again, the reason why we're doing all these is because, these are not square numbers, so we have to make them square. So in this case, we've got x minus 1 all squared minus square root of 5 all squared. Okay, the difference of two square numbers. Alright, so our rule, okay, I'm applying the same rules over and over again. Okay, they're just with increasingly complicated numbers. Okay, it's the first number, x minus 1 minus the second number, which is root 5, x minus 1 plus the square root of 5. Okay, so in this case, this is as simple as we can go. Alright, so we can, in the other ones we had constants, we could add and subtract numbers. Alright, now in this case, we can only add and subtract like surds. Alright, so you can't add or subtract root 5 to 1. Alright, this is actually as simple as it goes. So that's the answer there to that problem. Okay, so we do a lot of this in this unit, so even though this is kind of tricky to get used to, there's a lot of numbers and square roots and stuff, you do have to get used to it, so I think you really need to practice these. Now, just quickly, I'm going to go on to this last method of factorising, which we sort of talked about in class. You may have done it last year. Okay, so this is called factorising by grouping. So if you have a look at this expression here, there's some x's in there, there's some a's in there, but there's no number that you can take out of everything. And what we do in this case is we do something called grouping, and depending on how you're grouping, you'll get a slightly different method, but you should get the right answer. Some of the ones in the book, it's quite obvious what you do, some not so obvious. But you look at these two, and then these two. Okay, so it's factorizing by grouping in pairs. All right, so let's look at this first two expressions here. And if you look at these, there's actually a like term, a highest common factor of x. Okay, so what we do is with these first two, we take out x and we divide just like normal. X squared divided by x is x. Now negative x divided by x is actually, remember there's a 1 there, okay, so it's not 0. Negative 1x divided by x is going to be negative 1, okay. So the second group here, the second pair, there's a highest common factor of a, or let's do plus a. Okay, so we're going to plus positive a. We're going to take out a from both of these terms. So in brackets, positive ax divided by positive a is x, and negative a divided by positive a is negative 1. Okay, so you can actually also take out negatives, which will change the sign here. This is quite a simple example, but what you'll find in most of these is you'll be left with another expression you can factorize. Okay, so you'll notice that, remember we did these up here. Where was it? Okay, so remember these type. So when you had the two things, terms, the term in the bracket becomes the highest common factor. So we take out x plus 1, x minus 1 in brackets, and what's left is x plus a. Okay, so even though this one here is in brackets, okay, we're factorizing, we're putting back into brackets. Even though it is in brackets, it's only partially factorized. Okay, so it's actually, you need to go that extra step. So in a test, you'd probably get half marks. Okay, it's only partially factorized. It should actually say fully factorized by grouping. Okay, so that's the answer to that. Have a go at some of the questions in the book, and good luck.